before we move on to covering the formal definition of a convergent sequence, which is actually a very challenging definition to wrap our heads around, I want to continue with a little bit of our informal study of convergence. Informally, we're talking about a sequence approaching something. The thing that that sequence is approaching is called the limit of the sequence. And we want to remember that there are many ways to approach something. So that's one little caveat that will be important to us when we actually move into the formal definition of convergence. What I've done here is shown you a nice graphic that was created in Mathematica. That's another task that we'll be studying this semester, is how to use Mathematica to help us do some computational tasks and make some great visualizations. What I've done here is made 3 different sequences, each of which converges to 2. So in our little key, the orange line is the limit of each one of these sequences that I've named A of n, B of n, and C of n. The sequence A of n, the blue sequence, is approaching 2. You can see that as the index of our sequence is increasing, as we go further and further into that list, the values in the sequence are getting closer and closer to the limit, but they're always below the limit. So that's what our sequence A of n is doing. On the other hand, our sequence B of n is also approaching 2, but from above. These numbers in the sequence B of n are above the limit, but as we progress, as we go further into the indices, the terms are getting closer and closer to the limit, but are a little bit larger than the limit. Where things get very interesting is that it is still possible to approach a limit, but to sort of oscillate in the way that you do that. And that's what the sequence C of n is doing. The sequence C of n is actually approaching a limit of 2. It is true that as we go further and further into the sequence, the values that we're obtaining in the sequence are getting closer and closer to the limit. So this sequence is converging to 2, but it's not doing it nicely in the way that we often want to think about it. And so it's important to keep that in mind, that this behavior is possible and very acceptable as convergent behavior. It's okay to sometimes be above the limit and sometimes below the limit, and then to switch back and forth between those things, as long as you're still ultimately getting values that are getting closer and closer to the limit. So that's important to think about. And yes, we have seen examples of each of these types of behavior from the previous slide. So 4 of the sequences on this previous slide converge, 2 of them do not. The convergent sequences were sequences 1, 2, 5, and 6. So let me take you back there for a moment. 1, 2, 5, and 6 are your convergent sequences. Now sequence 1 has a limit of 1, and we are approaching that limit from below. The numbers here are getting closer and closer to 1, but they're always proper fractions, which are less than 1. Sequence 2 is approaching 0, but these numbers are all positive. So sequence 2 is an example of a sequence that is converging to its limit from above. Sequence 5 is interesting because it's giving us that sort of alternating or oscillating behavior that we were seeing in the sequence C of n in this image, where one of our numbers is below 2, and then our number is above 2, and then our number is below 2, and then our number is above 2. So this sequence is an example of something that is converging to its limit in an oscillating manner. And then sequence 6 is also approaching 0 from above, just like sequence 2. I'd also like to take a moment to talk about divergent sequences informally. Divergent sequences are somewhat difficult to define because we define them as a negative thing. They are the not convergent sequences. And so it's much more difficult to give a description of all the different ways that something can diverge as opposed to all the different ways that something can converge. However, I'm really lucky here because there are 2 common types of divergence that we see often in a calculus classroom. And also, luckily for me, the book Divergent helps us visualize what each of those are. So it can really give you a good ad hoc understanding of divergent things in mathematics. One of them is much like Tris. If you've read the Divergent series, she's called Divergent because she doesn't belong to just one of 5 factions. She seems like she could belong to many factions, and that is divergent because she doesn't just converge to one of those things. She can't make up her mind. She belongs many places. So that's one type of divergent behavior. Another type of divergent behavior would be the opposite of 4. Or in other words, something is unbounded. It's getting very large and is not staying small. And when I say it's getting very large, I mean in absolute value. Something can diverge to infinity by getting really, really big, but it's okay if something diverges to negative infinity. We would say it gets very, very small maybe, but that doesn't seem to really encapsulate the behavior. So I would say it's getting very, very big in absolute value. If you ignore the minus sign, the terms are getting very big. So we can diverge by going off to either plus or minus infinity, or we can diverge by having this oscillating behavior that never settles down. It just flip-flops back and forth, kind of like a sine curve. Those 2 remaining sequences from our example of 6, sequences 3 and 4, they do the behaviors that we're seeing here. Sequence 3 goes off to infinity. That 1, 4, 9, 16, 25 sequence, that sequence of squares is just getting really, 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 really big. However, the other sequence that we saw, the alternating sequence, negative 1, 1, negative 1, 1, that was never making up its mind. In fact, it was just like the peaks and the valleys of a sine curve, something that oscillates but never settles down. And that sequence was divergent in this other sense. I cannot decide if I want to be 1 or if I want to be negative 1, and since I cannot make up my mind and just trend towards one thing, I am a divergent sequence.